Welcome back. Welcome back. Today we are discussing about the construction and working of ruby laser. Ruby is the aluminum oxide, the transparent crystal of aluminum oxide, also known as corundum. It is a solid material, and hence the name, and hence the laser is the solid laser. And this solid laser was the first working laser designed by Theodore Neumann in the year 1960. And this aluminum oxide, called the corundum, is doped with the chromium oxide in order to get the pink color, is the color of the output laser beam. This aluminum and oxygen of corundum are inert, whereas the chromium is active. The chromium ions are active. And about the construction part, ruby crystal is in the form of cylindrical rod of about 10 centimeter in length, about 10 centimeter in length. The two ends of the rod are polished in order to provide the cavity for resonance of the emitted radiation. And while polishing, one end of the ruby rod is made highly polished, whereas the other end is partially silvered, through which the output is obtained. Now, the two ends of the ruby rod form a resonant cavity known as Fabry-Perot resonator. Fabry-Perot resonator. The active medium in the ruby is aluminum oxide, whereas chromium is the impurity added in order to get the pink color, which is active or active center. And we'll have a helical flash lamp. A helical flash lamp is surrounding the ruby rod, which serves as an optical pumping device. And this flash lamp is connected to a capacitor which discharges few thousands of joules of energy in few milliseconds. This flash lamp, which further this flash lamp which surrounds the ruby rod, is connected to a capacitor, and this flash lamp will discharge thousands of joules of energy in few milliseconds, because of which the entire apparatus gets heated up. So there will be a cooling system in which water will be circulating around the ruby rod and removes the heat generated. This is about the construction of ruby laser. Now we study how it works. So here you can see ruby rod, which is in cylindrical form of 10 centimeter. One end is fully silvered, the other end is partially silvered, across which the laser beam is obtaining. The flash lamp, the helical flash lamp is surrounding the ruby rod, which further connected to the capacitor C. And here the water circulation system is not shown in the diagram. Ruby rod is a three-level lacing scheme or lacing system. It will have two higher energy levels and one metastable state. When helical xenon flash lamp is fired, there will be an intense burst of light for a few milliseconds. When this flash lamp is fired, it gives out an intense light for a few milliseconds. Chromium ions absorb a part of this energy in blue-green region, half of wavelengths 400 nanometer and 660 nanometer, and will make transitions from ground state to level E1 and level E2. Level E1 and level E2. Now, chromium ions immediately decay to metastable state, and this decay is non-radiative. This decay is considered as non-radiative, and this will result in the population inversion, as the lifetime of metastable state is more compared to the lifetime of the excited state. In excited state, the ions can stay for 10 power minus 8 seconds, whereas in metastable state, they stay for about 10 power minus 3 seconds. Laser action will be triggered by the spontaneous emission of one of the photon, followed by decay of atoms to the ground state. And this this spontaneously emitted photon will further cause stimulated emission of photons of metastable state. And the process continues, the process will continue, and finally the metastable state will be depopulated. Once it gets depopulated, laser action will stop. Now laser will come out of the semi-silvered surface. Laser will come out of the semi-silvered surface, and the output of ruby laser is in the form of pulses or in the form of spikes. You will have certain limitations since during optical pumping, large amount of energy will be wasted in the form of heat. Now, there is a video clipping I will show you. So you can see that here it is the ruby rod in the form of cylinder of length 10 centimeter. One end is completely polished, whereas the other end is partially silvered, and this serves as the flash lamp. This serves as the flash lamp, the xenon flash lamp. Again, water circulation is not shown here. When the flash lamp is fired, an intense burst of light will enter into the tube, and these chromium ions will absorb light from or energy from the flash lamp and gets excited. They immediately decay non-radiatively to metastable state, and from metastable state, one of the atom undergoes spontaneous emission emitting a photon, and this photon will trigger further stimulated emission, and the photons emitted will be continuously moving, will be continuously moving between or reflecting between the highly polished mirror and the partially polished mirror. It will be continuously reflecting between the two mirrors or in the cavity, and finally laser light will be emitted out of the partially silvered surface. This is how the ruby laser will work. And once the what is called the metastable state is completely depopulated,